Hey, good morning, guys. Today, just want to talk about the smiley face factoring strategies for the trinomial, especially for the one that's typically for the quadratic trinomial. So factoring, there's so many strategies that we can apply, but one of the technique that I prefer the most is the smiley face. So factoring with the smiley face. So here's one of the examples that I just want to show you right here. So the first one. So let's start it off with 3x. Okay, let's see. So 3x squared plus 39x, and then plus 108. So first thing that you always want to check is the greatest common factor, if there's any. So 3, 39, 108. So all those three numbers, they're all divisible by 3. Well, 3 obviously, 3 and 9, 39, 3 and 9, the sum is 12, which is the multiples of 3, so the whole number is divisible by 3. And then 108, so 1 plus 0 plus 8, it's also the multiples of 3. So that means everything, it's all divisible by 3. So we got 3 taken out, so we got x squared plus 13x, and then plus 36, 36 remain. And then for the trinomial, so from here, the smiley face structure is about this factor tree of the first and the last term. And then we want to just make the smiley face like this. Well, I'm going to explain that what those curves mean. So we got x, if we just break down x squared evenly, and then 36. Well, there's so many combinations for 36. So there's so many possibilities. Could be 1, 36, 4, and 9, 2 and 18. So the one we want is that the sum of those two numbers must be the same as the number here in the middle. So the one that I select would be 4 and 9. And again, the curve right here, so we just want to check the product. So the inner product, we got 4x. And then the outer product, we got x times 9, which is 9x. So once you combine those two terms together, we got 13x. So this process is just like checking the word, making sure that it's the right factor. And that's exactly what we have. So now, you might be wondering the way that we put this all together for the factor tree. So anything that you have on the left-hand side of the factor tree, the one I'm circling right now, so those are the one that you want to put them all together. So we got x plus 4. And then the one on the right hand side, x and 9. So also you want to pair all those elements together. And here's your factor form for the smiley face. So now let's do another examples for this. So the one that I will select, let's just make one of the difficult ones. So we got 196 v to the power of 6. And then minus 324. So as you can see that here, 196, 324, those are big number. So those are considered even number because the last digit ends with an even number. So let's try to divide this number by 2, or perhaps the multiples of 2. So let's start out with 4. So 196 divided by 4, then that will give you 49. And v to the power of 6, simply bring it down. Again, what I did here, I just divide the coefficient by 4. And again, for the second number, so you want to divide that by 4. So we got 81. And for those you might be wondering, well, this one is like a difference of 2 squared pattern. It is a difference of 2 squared pattern, but the thing is that what happened, we don't recognize the formula or the structure. So you might be wondering, this one is only the binomial. It is the binomial, but we can always make up the missing term right in between. So the missing term right in between would be considered 0. Or we can say that's 0v to the power of 3. And then minus 81. And then from here, we just started with the smiley face again. So smiley face, factor tree for the first and the last term. And then we just want to check the inner product, outer product with the chin and the mouth. So what we got here, we got 7v to the power of 3, 7v to the power of 3. And then negative 81, we want to use negative 9 and positive 9. So checking the word here, 7v to the power of 3 times negative 9, we got negative 63 v to the power of 3. And then 7v to the power of 3 times 9, we got 63v to the power of 3. So once you combine them together, so that will give you 0v to the power of 3. So that means it's a right factor form. So the way to put this all together, so 4, well, which is the greatest common factor, so that's the first number, we need to bring it down. And then the left hand side of the factor tree, so what we got here is 7v to the power of 3. And then minus 9. And then for the right hand side of the factor tree, so we got 7v to the power of 3 plus 9. And here's the factor form for the binomial. So now let's just do one more example. So this one, I would like to start it off with 16v to the power of 6. And then plus 40v to the power of 3. And then plus 25. So first thing, again, you want to check that it's the greatest common factor. We got even, odd number. So it looks like they do not have any greatest common factor. So you always started with the smiley face without any greatest common factor. So what we got here is 4v to the power of 3. Again, the strategy for doing that, you always want to break down the number as close as possible or try to make the number even. So we got 4v to the power of 3 and then 4v to the power of 3. And then 25, so let's put in 5 and 5. So 4v to the power of 3 times 5, we got 20v to the power of 3. And then 4v to the power of 3 times 5 again, so we got 20v to the power of 3. And that's just 40v to the power of 3. And for those you might be wondering, well, this one is the perfect square binomial. It is. But again, if you don't recognize the structure, so you can always use the smiley face to check your work, to put into factor form. So left hand side, so we got 4v to the power of 3 plus 5. And then the right hand side, same thing, 4v to the power of 3 plus 5. And also you can group them together. So it's 4v to the power of 3 plus 5. And then the whole quantity squared. And that's the final factor form. So for those who like the video, so please subscribe my channel. And also for the future video, I'm going to put out more factoring strategy, like factoring with grouping and also factoring with the special formula, like the difference of two squares, difference of two cubes, and the sum of two cubes. So stay tuned. And thank you for watching the video today.